In this lesson, we're going to take a look at counterexamples when we see the quantifier unique in a particular statement. So let's consider the statement object X with property A is unique. What if we think that this statement is a false statement? Well, if we believe that this is a false statement, what we'd like to do is provide a counterexample. Recall that a counterexample is a numerical example showing that the statement is false. In our particular statement, we have object X with property A is unique. The quantifier unique here at the end implies that there's only one object X with property A. So a counterexample for a statement containing the quantifier unique is going to consist of two particular objects that both have property A. So let's go ahead and take a look at a couple examples. In our first example, we'd like to find a counterexample for the following statement. If U, which is the vector containing the components 2, 1, is in R2, then there exists a unique vector V in R2 satisfying U dot product with V is equal to 0. Now what I'm going to do first is I'm going to take a look at the property that our particular object has, and that is that U dot product with V is equal to 0. To form a counterexample for this particular statement, we'd like to find two objects that both satisfy this particular property. So let's take a look at the dot product between U and a general vector V. So the components for V here I'm just going to label as V1 and V2. Well, the dot product is going to be 2 times V1 plus V2. And we know that this dot product should be equal to 0 in order for our property to be satisfied. So if we look at just this equality right here, we could move V2 over to the other side so that 2V1 is equal to negative V2, and we could divide both sides by 2 so that V1 is negative half of V2. And I'm going to use this relationship between V1 and V2 to create two examples that are going to make up our counterexample. Let's pretend that the value of V2 is equal to 0. So what does that mean for our original vector V? Well, V is V1 comma V2. And if V2 is equal to 0, that tells us what the second component of V is. And then we can use this relationship to get the value of V1. So V1 is also going to be equal to 0. So here's one candidate for our counterexample. And let's get one more. Let's take a look at if V2 is equal to 1. Then we're going to have another V. We know our second component is equal to 1. And using this relationship up here, if V2 is equal to 1, then V1 is negative 1/2. So it's these two particular vectors, 0, 0, and negative 1/2 and 1, they're going to form my counterexample. The last thing we have to do is show that U dot V in each of these cases is equal to 0. So let's go ahead and do that. For our first vector, which is the 0 vector, clearly we can see that the dot product of these two vectors is going to be equal to 0. So the property is satisfied in this case. For our second vector, taking the dot product, we have 2 times negative 1/2, that gives us negative 1, and then 1 times 1 for 1. So yes, the property is satisfied for the second vector, negative 1/2 comma 1. So we have our particular counterexample. Okay, so let's unpack this just a little bit so you can understand the process. What we needed to do here was we needed to find two vectors V. So here are two numerical examples for V that satisfy the property that when we dot product it with U, we get the value of 0. So this tells us that this vector V is actually not unique. And our original statement must be false. In our next example, we're going to find a counterexample for the following statement. If A is a 2 by 2 matrix, then the 2 by 2 zero matrix, which we're going to denote with capital O, is the unique matrix satisfying A times O is equal to O. To begin this example, we're just going to choose a 2 by 2 matrix. And we want it to be fairly simple to work with, so I've chosen this 2 by 2 matrix, 1, 1, 0, 0. And then next, notice that when we do the multiplication of A times the 2 by 2 zero matrix, we do indeed get the 2 by 2 zero matrix. So there exists at least one object satisfying this property. We just don't know if the 2 by 2 zero matrix is the only object satisfying this property. So in order for us to disprove this statement, we need to find one more matrix that we can multiply A by and get the 2 by 2 zero matrix. So let's try to construct this matrix B that we need. We know that we want A times B to be equal to 0. If we can find this matrix B, then we have two objects that satisfy the property, so the 2 by 2 zero matrix is not going to be unique. So let's call matrix B A, B, C, D, and we can expand out the left-hand side by doing matrix multiplication. We'll get A plus C as our first entry, we will get B plus D as our second entry, and our two bottom entries are going to be equal to 0. So we would like this matrix to be equal to the 2 by 2 zero matrix, and this implies that we must have A plus C equal to 0, and we must have B plus D equal to 0, or in other words, we must have A is equal to negative C, and also equivalently B must be equal to negative D. So if we take A and B to both be equal to 1, then we have C and D are both equal to negative 1, and our constructed matrix B looks like this. So the last thing we want to do is just check this multiplication. What does A times B equal? So doing our first multiplication, we're going to get 1 times 1 plus 1 times negative 1. That's going to give us 0. Our second entry is going to be similar. We'll get 1 minus 1 for 0. And because of our full row of zeros here in the second row of A, we are going to get a full row of zeros in the product A times B. So we found another object that satisfies the property from our statement. So the 2 by 2 zero matrix is not the unique matrix satisfying that property. Hey everyone, thanks so much for watching this video. If you click here, over here on this beautiful YouTube logo, you can head over to my channel to see some videos for my other math courses. You can also follow me on Twitter for updates for your course or to ask questions. Alright, my little epsilons, stay positive. Just erase that previous part. That previous part just didn't even make any sense.